Okay, Jacob, so here is the second page you sent to me. So it says we want to find the orthocenter. Again, the orthocenter is the intersection of the altitude. So we're going to start by graphing. I'm going to use double units here. So we have negative 5, I'm going to call that 1, 2, 3, 4, 5. So it's negative 5, and then we're going to go up 4. That's 1, 2, 3, and 4. So that's going to be our coordinate x, negative 5, positive 4. And then y is going to be positive 2, negative 3. So we'll call that 1, 2, and then negative 3, 1, 2, and 3. That's our y. And then z is going to be at 1, 4. So over 1, up 4. 1, 2, 3, and 4. That's 1, 2, 3, and 4. So there's z. So our goal is to find the orthocenter here. And all you have to do is use two sides. Any two altitudes is sufficient. So step one is you want to find the slope of all three altitudes. So we, of course, know the slope of this is 0. It's horizontal. The slope of this one, y minus y over x minus x, that's going to be negative 4, positive 4 minus negative 3, and 1 minus 2. So the slope here is going to be 7 over negative 1. So that's the slope of this side. And the slope here is going to be 4 minus negative 3 again. That's going to be positive 7, negative 5, minus 2 over negative 7. Therefore, it is negative 1 to that line. So the first thing I want to do is choose my slope here. So I'm going to draw an altitude and make it at a right angle, and we know that the slope of the line perpendicular to this is going to be positive 1. So down 1 over 1, down 1 over 1, positive 1. And now we need to find the equation of that line right there. We'll call this z. Let's choose a coordinate here, zw. So my slope there is going to be positive 1. I don't know my y-intercept, so I do y equals mx plus b. And my slope is positive 1. My x is positive 1. My y is positive 4 equals, and my b. And then you solve. And of course that's going to be 4 equals, and that's 1 plus b minus 1 both sides, b equals 3. So the equation of that line is going to be y equals 1x plus 3, which if you look very carefully, there's your intercept right there, so we know we're correct. So this is y equals x plus 3. All we have to do is find another altitude. Okay, what you're probably noticing here is that we have an obtuse triangle, which you need to understand that when you draw the altitude either from x or y, the altitude is technically, in this case, going to go outside the triangle. So here, we were over 3, over 2, and down 3. 1, 2, and 3. That means to draw a straight line, we have right here, straight line, going opposite to the other side, at a perpendicular, technically that is x equals 2, and that is outside the triangle. So we have to find the intersection of these two lines. So if you extend this line, we can see that our orthocenter, at least in this case, because in its obtuse triangle, it's going to be outside the triangle. So we're looking for that coordinate right there. So we know our other red altitude is x equals 2. So now we want to find the intersection of that. That means one of those coordinates is going to be 2, comma, then something. So we take x equals 2 and we plug it in right there. We're going to end up with y equals 1 times 2 plus 3. Obviously our y equals 5. If you look over here, remember I used double units. So that's over 2, and we go 1, 2, 3, 4, and 5. So your coordinate here is going to be 2, 5. That is where your orthocenter is. So the rule of thumb here is that when you have an obtuse triangle, the orthocenter can be outside. So don't be intimidated by the fact that you may even be working outside the triangle. Just draw in your two altitudes, find the equations of those lines, figure out when those equations of lines intersect. So there's your two altitudes. I'm just recapping here. The first altitude was inside the triangle. The second altitude was outside the triangle, creating a right angle right there. And then they intersected at that hot pink, which was 2, 5.